Wonderful. Welcome, everyone. I'm Brian Effelman, Senior Director of Product Marketing. I'm joined by Gabriele Weber, as well as Tim Sanguinetti. And we're going to be talking about Arc Embedded today. This is a new feature that we launched last month, and it provides the visibility and security into the lowest levels of the OT and IoT network. This is what the next hour or so is going to look like. We're going to talk a little bit about OT and IoT security frameworks and how Nozomi Networks protects them. We're going to give a baseline about Nozomi Arc, which is a product that we launched 2 years ago, but I think it's important to understand the basics before we dive into Nozomi Arc Embedded. Again, this is a brand new solution that we launched in the market last month, and we'll go through the key features of the solution, customer use cases, and hopefully have some time for Q&A. We're going to start off with a networks solution portfolio overview, which Gabriele is going to walk us through.
For sure. So we started about 11 years ago with our foundation product that is called Guardian, our first sensor. During time, we have added more sensors, and Arc and Arc Embedded are two of those new sensors. We got Guardian Air, which is the first OT IoT wireless sensor. We got remote collector, and then as well as we have several add-ons to our solution: Vantage IQ, Smart Polling, Threat Intelligence, and Asset Intelligence. Most of you may be already acquainted with all of this. Along with, we have some management solution on-premise and our flagship product nowadays, which is Vantage. And again, as Brian introduced, the focus today is Arc Embedded, passing by what Arc is, where it comes from, and then diving into more details for the embedded version of it.
Perfect. Well, maybe we start with that overview of Arc Embedded. Gabriele, do you want to walk us through that?
Let me talk about Arc in general to start.
Oh, sorry, not Arc. Yeah, not Arc Embedded, just the Arc endpoint sensor. Yeah.
Arc endpoint. What Arc endpoint sensor is a user space software which we install in our customers' networks, compatible with Windows, Linux, Mac OS, and now embedded devices architectures as well, to increase visibility in the networks. So, as you know, we need visibility to then enable for all the rest: vulnerability assessment, threat intelligence, and asset inventory itself. What Arc does is increase, or better say, decrease the time to value, time to visibility. So what is the time to visibility or time to value? It's about you installed in a Nozomi solution, you start collecting traffic, and then there is a point in time where value happens because you can start taking educated decisions on the network. Now, with Arc, we basically improve this product, this process. We make it faster, and then decrease the time to value. This is the main reason that led us to introduce Arc. Why do we call it endpoint sensor? Next one, please, Brian.
Yeah.
We call it endpoint sensor because it has gotten two levels, let's say. It acts as an asset sensor and as a network sensor. From an asset sensor point of view, these are the main features we offer with Arc, and they range from physical device access. Basically, we can monitor USB communication, spot malicious USB devices, and such, spot file transfers over USB. As we know, in OT and IoT infrastructure, physical device access is very, very important together with the rest. So USB, physical device access. User activity correlation. Think of an incident response, incident investigation, how important it is for accountability purposes to connect an action, to connect an alert to someone that was connected to a given workstation, connected to a given HMI. Now, with Arc, it is possible. Behavior analysis, and we do this via Sigma rules, which is a standard syntax for writing rules, driven by the security community, by the way. And this is also new for us. Nozomi has been all along a network-based solution. Now, for the first time, we can be on the asset, on the endpoint, and we can spot events that just reside on the asset without traveling the network. Okay, so we complement our threat detection with local events together with network events for full-blown correlation. Continuous asset monitoring, MBA, is basically deep asset identification. It's about performance management of your devices. It's about knowing installed software. It's about knowing installed hotfixes. So the visibility that you cannot have just by listening to passive data traveling on the network. And then this is more of a preview, protection. We are investigating here exactly where to take this feature, but for the first time, taking real action against what happens in the network, blocking events. And this was Arc as an asset sensor. Next one, Brian. Endpoint sensor. Next one, please.
Yeah.
Okay, sorry. Perfect. So endpoint sensor, because we transform the endpoint into a Nozomi network sensor, in fact. And these are the three main items: continuous traffic monitoring, so passive communication, sniffing, together with discovery, which is lightweight, standard network communication to discover neighboring devices, together with smart polling. And you may know smart polling is surgical queries to extract information from devices using dedicated protocols, depending on the controllers or workstation or asset type we're getting data from. And this is, in a nutshell, what Arc does and is. Next one, please, Brian, and back to you.
And, thank you for the overview. And now what we're going to talk about is how we're taking all of that Arc functionality and dropping it down to the lower levels of the network to provide expanded coverage, expanded visibility, and better protection, faster remediation for levels 1 and level 0 of the Purdue model. You're all here because you probably saw the press release that came out last month where we announced Arc Embedded, and this is truly the world's first security sensor, endpoint sensor embedded in ICS systems. That gives us the ability to extend that visibility and control down to field assets, all the way down at levels 1, and visibility into level 0 traffic as well. I was talking with customers a few weeks ago, and this notion of innovation, being synonymous with Nozomi, Nozomi being synonymous with the word innovation. It's actually what they said. And this is a snapshot of all of the innovations that we've had, over the past decade plus. Starting with Vantage, so the industry first AI rules-based engine. We also launched Guardian Air earlier this year, but this is the industry first that we're talking about today, Arc Embedded. And again, that's the ability to extend visibility and control all the way down to the operational level. We're going out the door with this capability at first with Mitsubishi Electric. They came to us and said, hey, we want to understand how we can provide better visibility and security at the controller level. So we developed this solution in partnership with them. This is the first foray into protecting controllers and controller environments and being able to see all the way down to the field level assets. The functionality is going to be available on their IQR series. It's going to require a separate module sold separately from Mitsubishi, sold through, it'll actually be a Nozomi solution. It's going to be globally available, but distributed through Mitsubishi at first. So with that, I'm going to hand it back to Gabriele for an overview of Arc Embedded and the capabilities that we're delivering.
Perfect. Thank you, Brian. So yes, as you said, we've been working with very closely, by the way, with Mitsubishi Electric in the last months, and we are very happy. We are putting out this product on the market. I think the overall topic here is that we see what is the potential of this, and we want to extend it also in the future, possibly to other vendors. And the idea is, in fact, to move down to the levels of the network with this sensor, with more automation vendors, etc. So if you go to the next slide, please, the way I like to see this Arc Embedded is how Nozomi is proliferating in the customer networks. So we came up 11 years ago with a physical appliance that's a Guardian sensor. Then we provided support for virtual machines for the same appliances. And then we eventually moved also to containers. And this is for external sensors, network sensors. In 2023, we introduced Arc, and for the first time, we are on the endpoints. So we are transforming workstations, HMIs, into Nozomi sensors. And now we are transforming even PLCs or other similar embedded devices into Nozomi sensors. This is a breakthrough in the industry. This is something really innovative, as you say, Brian. We are soon doing more research and development on this, so more to come, but this is what we are presenting to you today.
Excellent. One of the reasons I'm really excited about this offering is this has been a customer problem that's been around for over a decade. And when we look at OT networks, they've been built, security of OT has been built in the same fashion as IT, meaning it's a very north-south model. And with that, the ability to secure that level 1 and level 0 traffic, that's where security in OT network has basically ended. And so what we're providing here with Arc is the ability to have visibility, anomaly detection, and control of that traffic at levels 1, and the visibility all the way down to level 0. Many vendors have tried to solve this in the past with a patchwork of solutions that might have ACLs and separate VLANs, or might be able to provide identity control solutions at the PLC level, but they required separate security devices. So it was very cumbersome, very costly, difficult to administer, and difficult to really extract any valuable information from. And so with Arc, we have the ability to see all of that backplane data behind the PLC, do analysis on that, pass alerts up through Guardian and through remote connectors, and do advanced analysis on the traffic that we're seeing down at levels 1 and level 0. So it gives us visibility all the way down to the factory floor. It's a revolutionary approach. We are the first to market with these capabilities, and it leverages our award-winning AI capabilities as well in order to provide better anomaly detection, better threat mitigation. And because we're sitting down there all the way all the way down at the footprint of the network, it gives us the ability to respond faster to anomalies and threats. And that's one of the major advantages of the solution. And Gabriele, I'm going to pass it back to you to walk through some of the key features here.
For sure. So as you can see from these Arc Embedded main features, some of them we want to repeat the ones that are in the classic Arc, because in fact it inherits all of them. But I want to give more emphasis to a couple of these blocks here. And one is serial and backplane data detection. So Brian just mentioned that many times PLCs have remote IOs components that are connected through non-Ethernet communication. Now, thanks to Arc Embedded, we are getting more able to get the data out. So how many components are part of that PLC, who does what, even though it's on serial and it's not on Ethernet, okay? When it comes to continuous asset monitoring NVA, please remember Arc Embedded is a custom version of Arc, so it inherits all the characteristics of it, plus we want to develop every time something specific to the environment that's around. And for Mitsubishi, in fact, we have done that. And it's about knowing more information about the PLC that is not natively available when you install a classic Arc. And a very important one, status and status changes. Okay, so imagine from within the PLC to spot ladder logic changes, program changes, and we know how important it is. What is the program running on a PLC for the sake of the automation of the process functioning? spot if there are differences, if there are changes, if there is a hack over there. And now we're able to do it from within the PLC. Quick mention about traffic monitoring, discovery, and smart polling again, because as Brian mentions, we are at level 1, and the east-west communication he mentioned is now accessible through within the PLC monitoring around. Back to you, Brian.
I think actually what we're going to do now is we're going to go through the use cases that we specifically address with Arc Embedded. And so, Gabriele, will you take us through some of those?
For sure. So coming back to the time to value or time to visibility concept I mentioned earlier, I want to emphasize on this how when we rely on someone else's devices reconfigurations, visibility is suboptimal. Now, when we connect a classic Nozomi sensor, Guardian or a remote collector into a network, we connect into spam ports, mirror traffic, right? Now, we are in presence of different types of switches. Some of them are not managed. With some of them, we encounter some challenges simply because the automation vendor may not be willing to change some configurations. There is some warranty related risks. And so basically, we are not able to show our full-blown Nozomi potential just by a network sensor. This is why Arc helps us facing this problem, solving this problem, right? So again, transforming an endpoint into a sensor, we don't rely anymore, or we rely again, but we complement the visibility with this. So also in terms of deployment, we're basically just faster and to show information. Next one. There are several environments that are not only harsh, but difficult from a connectivity point of view. Air-gapped limited connectivity. Here we bring the example of a vessel. And we may still want to acquire data from those environments because we want our visibility, right? So we didn't mention it here in this presentation, but there is an Arc operational mode, working mode, which is called offline, which allows to collect the data, make an archive, and then basically move the archive and copy it into Guardian or Vantas. And here again, turning a computer into an Nozomi sensor without installing other hardware and not having connectivity to rely on, that's something very new. So this is the use case number 2, air-gapped and limited connectivity devices combined to offline mode. With the introduction of Arc for the first time, we are able to provide a completely hardware-less, infrastructure-less monitoring network, okay? Because we can connect Arc directly to our Vantas cloud solution. We don't need a physical appliance. We don't need a virtual machine. And data monitoring happens like that without any infrastructure deployment. So this is the use case number 3. So Brian mentioned several times the Purdue model, the level 1, the level 0. We have come up with smart polling, our active queries, as mentioned in the beginning, technology back in 2018. This is great. It helps us a lot. But now combined with Arc, it reaches a new level of potential. And why? Because of Purdue model. So in this picture on the bottom part, we see a Guardian trying to poll those workstations, but because they are separated by a firewall, because of network segmentation policies, network policies, we are not able to poll those devices. Now, for the first time, because Arc equips smart polling, we can act from the workstations themselves without going through any router. So basically, we can get maximum visibility without breaking any Purdue model / network policies. And this, we want to iterate a lot of this because we think is a breakthrough. For the first time, we have a level 0 and 1 visibility. So we have PLCs, and with connected sensors and actuators by residing on the PLCs, we can get an unprecedented visibility of these levels. Again, we would like to iterate on these serial components, remote IOs or similar. With Arc Embedded, we are in the most privileged position to get access to that information. Sometimes we are able to do it also from the workstation. We rely on the workstation, but here is the most privileged position to see this information.
Okay.
And this is just a graphical representation. This is our well, Mitsubishi setup we have used to go out with the first version of Arc Embedded, showing in fact the main PLC, serial cable over there, a remote I/O, and we are able to spot the information, the hardware components, all the data coming from that serial-based remote input-output.
And now what we're going to do, Gabriele, is just do a quick wrap up and future vision for Arc Embedded. I'll let you take that one.
Yes, just to summarize all the information we gave in the previous slides, and to say that what we have today is something real, and what we see as potential, we foresee as potential for Arc Embedded is great. Again, all the Arc native features are there. In particular, for the Mitsubishi case, we are relying on a Linux intelligent module. So every detection that is present for Linux, we are inheriting it and then expanding it with custom detections, as mentioned earlier. Maximum network visibility, because we can enable for east-west communication from two PLCs. These two I really love, and again, this is in projection for what we want to do in the future. Protection and compliance. Imagine to stop a process, to stop a network communication from within the PLC. Okay, so there is an attacker coming in, there is some actions, there is some fishy stuff happening, and then we'll be able to stop anything not from 2 hops away, not from 3 networks away from the very PLC itself. And likewise for compliance as well, that's something we are looking into for the next year, most likely. Maintaining an aligned fleet accordingly to company policies or state counter regulations. Well, compliance in a word. We'll be able to do it not only for workstations, not only for other devices, but also for PLCs themselves, enforcing a given baseline which is defined for those PLCs. Again, in terms of network connectivity, processes running, and so on and so forth. Continuous asset monitoring and VA. VA is always one of the most wanted pieces that our customers look into, and we have partially solved that, in fact, with smart polling, and we are happy that we're expanding it, where we are tackling it more effectively, even with Arc and Arc Embedded. Chain configurations, mentioned several times in this presentation, serial communication. Program changes, once again, checking for ladder logic changes from within a PLC, and the level 0 visibility. This wraps up what we see as potential for the technology in general, also apply to future technologies, future vendors we're going to collaborate with to develop something similar than we did with Mitsubishi.
Okay. We have a couple questions in the chat. Gabriele, if you want to take a look, one of the first questions that came up, and I saw this come up twice, is is it designed to be cross-vendor in a modular manner? And I think what the person who's asking the question is is this going to be available on multiple PLCs today? Again, the first foray into this is going to be with Mitsubishi. So that's the first platform that we're launching Arc Embedded on.
That's correct, Brian. And let me emphasize on this concept. An Arc Embedded is an Arc on top of which we have developed some detections, some capabilities that are proper and applicable and suitable only for the, in this case, Mitsubishi environment on which we rely on.
Yeah.
Okay, so this is why it doesn't make it cross-platform. It makes it Arc Embedded for Mitsubishi. So to extend it, we'll need to do R&D, research and development for other vendors in a separate, with a separate time, let's say.
Yeah. Another question that came up is, is this purchased by the manufacturers or is this purchased by the end user? And this is going to be purchased by the organization that's running the OT and IoT network. So this is going to be purchased and deployed by the end user. Gabriele, with that in mind, I'm wondering if you could talk a little bit about the ease of deployment on the PLC. So if you have, an Arc embedded enabled PLC, which is Mitsubishi today, how easy is it to deploy, on the PLC? How does that happen? Yeah.
Yes, for sure. So as any other feature, native Arc feature, or in this case, Nozomi Networks platform features enabling for Arc, like the automatic deployment that is available today from Guardian can be applied also to Arc installed onto Mitsubishi PLCs. So basically, we can select a machine on which to deploy, and then it's going to deploy it. We need credentials for that machine, for those machines, and it can be done on a bulk way. So super easy, super fast.
Yeah. There's a question about connecting into the backplane, and again, part of the question, it's coming from Matthew. Will you be able to accommodate additional PLC footprints in the future? That's something we're looking at. But connecting into the backplane data and the ability to see that data gives us more insight into operations of the entire network, not just what's happening on the security side. Is there anything else that you can give us in order to enlighten us as to what seeing that backplane data can help the network operators achieve? Gabriele, any thoughts there?
In general, what it helps us achieve is full visibility, because when you get some device pieces, you want to have a complete overview of what hardware components are connected to it. So it falls into the bigger picture of full visibility. In terms of the Matthew question, is this connecting into the backplane? So we stay generic in this presentation because depending on the case, we envision we'll be able to achieve it in different ways. In this case, Mitsubishi case, we obtain it by combining Arc Embedded and smart polling. But smart polling acts onto the Ethernet part. So basically, we ask a question to the PLC, and the PLC tells us what's behind. So we are not implementing serial communication per se, but we are asking the PLC what's behind, and as such, we get that full visibility.
Okay. Anything that you can, one of the things that we're going to be writing and delivering in September as part of this, and one of the last questions that came through is, safety and security, compliance. So we're going to be diving deeper, in some use case and case studies as to how Arc Embedded enhances those. Do you have any thoughts on safety relevant applications for this? I mean, obviously, if we keep the factory running as it should be, that's going to increase safety. A lot of organizations who are running OT networks are in heavily regulated environments with regulatory and compliance concerns. So this augments their capabilities to be compliant. But Gabriele, any thoughts on compliance and/or physical security and how this?
Yes, well, on compliance, it's something that comes up to us more and more often. How to enable our users, because we are lucky, let's say lucky, to have a lot of customers' networks information nowadays, detecting multiple protocols, having access to many communications, and how to make the best use of that to provide compliance. This is an ask that we have been receiving, and we are in fact checking how we can best do it, combining our platform pieces. And I would say the nice part is that by this we can do it directly from the endpoint, and I mean by Arc. And then by Arc Embedded, we can do it directly from the PLC, and that's already good. And when it comes to expanding it, as I was saying earlier, to protection, so to taking actions, we will do it in the fastest way because we are already on that machine. So I think this is pretty cool. Keep with us to see where it's going in the next months. We have several surprises in mind.
Excellent. We've covered a lot of these. This one's kind of a loaded question, Gabriele, and so if we can't answer it today, we'll be providing again. This is going to be another use case document that we're going to be producing over the next 2 weeks. But how do we, when Arc is running on a Windows machine, how do we keep those Windows machines from crashing, as you might see with traditional IT endpoint security solutions?
Okay. So when we designed Arc in the first place, even before Arc Embedded, we had in mind that we are serving critical infrastructure. We're serving challenging verticals, right? Oil and gas and power systems and all the rest. And then all the design has been in that direction. This means that first of all, we are a user space software. We don't want to write our own drivers for the most technical ones of the audience, or going too deep into the machines to avoid security events because of us. Okay. From a performance point of view, also we are super light. Okay, so I challenge you to test us. Basically, and we can tune also the amount of memory we allow our endpoint sensor to use. What else? Of course, this is OT IoT driven, because all the protocol knowledge and the detections we have, the traffic that is collected by Arc goes to Guardian and Vantage. And what else? I think this is it. So we thought of a product that is really suitable for that in several aspects. If you go and check our user guide, which is available online, by the way, you will find the several security measurements we took to best serve these networks. A native IT product will never have all the protocol and vertical information that we have been acquiring during our life. So that's pretty much it, in my opinion.
No, I think that's right. And, I touched on that earlier that, you can't take this typical north-south IT-centric mindset into an OT network, into an IT network, IoT, critical infrastructure network. The solutions are great. They're award-winning for IT, but they don't always apply to, OT-specific use cases, OT-specific deployments and devices. With that, I think we've answered, there are a lot here on performance that I think we've hit as well. Gabriele, do you see any others that
I didn't scroll all the questions, I must be honest. So I also invite participants, if you want to speak up, if something is not answered while we scroll, we can also have a conversation here if you wish.
I think maybe we'll end with this. Can we get a copy of the recording? There will be a copy of the recording posted to our website, and we will hit everyone who attended today with a PDF version of the presentation as well. So look for that. Look for a link to the recording so you can go back and listen again, share it with others, and With that, I want to thank everyone for joining today. Thank you for your time. Thank you for your questions, and especially thank Gabriele for walking us through the fine details of Arc and Arc Embedded. So with that,
Thank you, Brian. Thank you, everyone.